Remember when I said that we have to learn some physical properties about transition metals? And then I stated that they don't have to follow those normal patterns that we see with the main group metals and non-metals, but they have their own trends. Well, we've come to that part of our journey, folks. We can now kind of get out a periodic table if you like to create small trend lines, but our focus for physical properties are going to be atomic size, electronegativity, which is going to be affinity for electrons, and ionization energy, which basically means the energy required to remove an electron. Since we are talking about metals, and they tend to be they tend to form oxidation, right, or loss of electrons. So here you will see trends for our periods for transition metals here. And so I'm just going to write a couple of boundaries just so it's easier for us to see things and see those trends. So we're going to focus on our atomic radius first. And in main group elements, atomic size decreases across a period. So remember, we're going across a period. This is going to be usually from left to right. So in our main group elements, atomic size is going to decrease across a period. But with transition metals, atomic size decreases at first, but then remains relatively constant. So we can see there's some increase here with our scandium and titanium, but they basically remain constant as we go across the actual period. Now, with electronegativity, when it comes to main groups, electronegativity is going to generally increase across a period. That's what we usually see for main group elements. But as you can see with our transition metals here, they have a relatively constant electronegativity. Okay? So as you can see, they have kind of a constant here between 1.3 up to 1.9 and then 1.6. And so you can generally say that they have more intermediate electronegativity values. Again, we're only seeing period 4, so I'm talking in general as well. And then finally, ionization energy. With main group elements, ionization energy is going to rise from left to right as we go across. But with our transition metals, ionization energy is going to be relatively small across the transition metals for the periods here. Okay. So that means that we have relatively small increases. So you can see we're still in the 600s, still in the 600s. Yes, we went to the 700s, and now we generally stayed there. So because we have such small, yes, there are increases, but they're relatively small across the transition metals. This mainly is due to the fact that it's going to be harder to make those electrons kind of have any kind of connection to the nucleus. And so what I mean by that is reactivity is all about having that nucleus be able to be attracted to electrons so these bonds can form, right? But when you have these inner electrons or d orbital electrons as well, sometimes they can shield the nucleus, and because of that, you can see it kind of these stable numbers as we go across a period. Well, if we want to cross a period, what about if we go up and down groups? Okay, well, these vertical trends, which again are going to be up and down, they also exist as well. That means they're also going to be different for our transition metals than they would be for our main group metals. Our focus this time around is going to be still atomic size, electronegativity, ionization energy, but now we're going to include density as well. So when we're thinking about atomic size, we automatically have to think of volume as well, because the larger it is, the more space it's going to take up. And so atomic size and volume are going to be inversely related to density, because density is going to equal mass over volume. And what this really means is it's just going to tell us how closely packed these atoms are in their solid form. And so we get to learn more about this in 10.6 chapter. Of course, this could be a small amount of review for Chem 101 as well. So let's get to it, atomic size. As you can see, for our atomic size or atomic radius, the transition metals are going to increase down a group. Okay, so they're going to increase as you go down the group here between 4 and 5, but they're basically going to stop the increase after that. So anytime we're looking at any of these graphs, the orange is going to be our period 4, the blue or purple is going to be period 5, and 6 is also going to be that like lighter blue. Okay, so if we're talking about within a group, that means we're going from 4 up to 6 here. We're going from 4 up to 6, 4 up to 6, and so that's kind of the trend. And so when they're saying that we're going down a group, for example, just think that this is all in reverse. So as we go down this group here, we do see that there is definitely an increase between 4 and 5, but then when you get to 5 and 6, it's really hard to distinguish these two purple and blue lines here. All right, electronegativity, there is an increase again between 4 and 5. 4, 5, and 6 is going to be this color here. So there is an increase between 4 and 5, but a similar thing is that it's going to be basically no further increase from between 5 and 6. Yes, there are some exceptions like gold here. Gold is just very, very heavy. Okay, so because it's very heavy, it actually likes to be more electronegative and can kind of have more of a covalent character. So there's a lot of smaller details that you can get into when it comes to these transition metals too. But a lot of times when you do start seeing everything kind of merge, it's definitely going to be due to that shielding in those inner electrons, shielding that nucleus so that everything kind of remains constant. Okay. Now let's go down to ionization energy. As you can see, it's really going to generally increase down a group. So again, we're going to have our 4, 5, and 6. You kind of see a general increase as you go down a group. Now, if you're going to increase the ionization energy down a group, that means you're also going to have your reactivity decrease. Okay, folks, we'll talk about that later too. And then finally, we have our density here. So density is going to increase down a transition group. We're definitely going to increase down a transition group, as you see here. Because of those atomic sizes and thus atomic volumes is going to be increased. Period 6, or the ones that we see in this light blue here, our lanthanides, are going to be some of the densest elements. Now, they're not just lanthanides, because we know that's our inner transitions. They're also going to be like our hafnium that we saw earlier as well. Also, examples like gold, tungsten, platinum, they're all just extremely heavy. So you can start recognizing that just based on us understanding electron configuration and atomic properties, we now can start building up these physical properties. And guess what? Some things like ionization energy can help us understand reactivity when it comes to chemical properties too. And so we'll just continue on to build on to our chemical properties next.